So based on our p-value, what is the conclusion that we made? Number 27. So my p-value is 0.4180. So my conclusion is reject or not reject? Do not reject. And what does that mean? You do not have evidence of what? Yeah, Starburst and Jolly Ranchers have different proportions of cherry candies. Yes.
Say our z score became 0.81, right? Positive number, and we go under the z chart, and we see that it was I think like 0.710. Do we right away then after we get that multiply by 2 the other term, or we subtract it by 1 first?
So if you get a positive z and you look it up in the chart, you will have to subtract from 1 so you get the tail area.
Is that what it makes sense?
Because your p-value is a probability. So if you ever get a number bigger than 1, you know you've made a mistake.
Is there on there talking interval of 0.05? Do we have to figure that out?
Sorry?
Is there something about a confidence interval of 0.05? Did we have to talk about it? The question right before this one says 0.05 context. It says perform a hypothesis test of the 0.05 sample. What is that? It's just saying that.
So it says perform a hypothesis test at the 0.05 significance level. And that's what questions 23 through 27.
So the way we solved it here.
So by answering questions 23 through 27, you have performed a hypothesis test at the 5% significance level. Right. So what is the conclusion you make? You're using the 0.05 significance level. So I think we'll have time for this one, and we'll run out of time here, okay? 28 to 33, it says, researchers want to know if drinking caffeinated drinks improves reaction time. They randomly select volunteers in a blinded experiment, give some of them caffeinated drinks and others non-caffeinated drinks. Then they record reaction time. 30 people had a drink containing 300 milligrams of caffeine. The average reaction time was 580 milliseconds with a standard deviation of 110. 25 people had a drink containing 0 milligrams of caffeine. The average reaction time was 640 milliseconds with a standard deviation of 130 milliseconds. Is this evidence that drinking caffeine improves reaction time? So it says when performing a one-sided hypothesis test with alpha equal to 0.05, what should the hypotheses be? Okay, do we have one sample or two samples? Are we dealing with means or proportions? Two samples and means. Okay, so our null hypothesis is going to be mu1 minus mu2 equal to 0. When you have two samples and you're dealing with means, your null hypothesis is always mu1 minus mu2 equals 0. the alternative, okay, so mu1 corresponds to the reaction time of those with caffeine, and mu2 is the reaction time of those without caffeine. We're asking, does caffeine improve reaction time? So should mu1 minus mu2 be greater than 0 or less than 0?
Greater.
Okay, what does it mean to improve your reaction time? Do you get faster or do you get slower?
Faster.
Faster. So does it take you longer or more time or less time to react?
Oh, okay. Then it's less.
It would take less time to react. So if you had caffeine, would your reaction time be larger or smaller than without caffeine?
Smaller.
Smaller. So it should be mu1 minus mu2 is less than 0. Is that okay? Alright, so continuing on, I'm just going to work very quickly here. Observed difference in means 29 is going to be x bar 1 minus x bar 2. So I have 580 minus 640. And I get negative 60. Number 30 asks us for the test statistic. So, actually, number 30 is going to be x bar 1 minus x bar 2, technically minus 0, divided by the standard error. My standard error is going to be 110 squared over 30, plus 130 squared over 25. I get a standard error of 32.85. So I get negative 60 over 32.85. I get negative 1.826 as my standard error. Going on, what is the p-value? Okay, how many degrees of freedom would I use? N minus 1, but I use the smaller group,
24.
so I have 24 degrees of freedom. And my test statistic is 1.826. We see that it's between 1.711 and 2.064. If you go to the table, 1.826. So your p-value is going to be between 0.05 and 0.025. If our alpha is 5%, do we reject or not reject the null hypothesis? If alpha is 0.05, our p-value is less than alpha.
We reject.
So we reject the null hypothesis. And we have evidence that caffeine reduces reaction time, or improves reaction times. Okay, I think we've run out of time, so please continue working on the practice final. I will post some solutions up online so you can compare your work. I'll see you guys next week. Good luck as you study, and see you at the final exam.